Let's concentrate now on deductive arguments and analyzing their validity. An argument is said to be valid if its conclusion is guaranteed by the premises. So in other words, the conclusion must happen based on what the premise is saying. And that's regardless of whether the premise or the conclusion is true. We don't really care when we think about validity whether the original premise was true. What we care about with validity, and this is how validity is defined, is whether the conclusion is guaranteed if the premise occurs. An argument is said to be sound if it is valid and its premise are true. Okay, so soundness is when we actually bring in truth. For the most part, we're going to concentrate on validity for our examples because sometimes the truth part can be a little tricky, whereas whether an argument is valid or not is usually fairly easy to prove. All right, so let's take a look at doing that. So we can analyze deductive arguments for validity by examining the information provided by the premises and looking at the conclusion in conjunction with that. And also we can do it by drawing Venn diagrams. And we're really going to emphasize drawing Venn diagrams because they can really help us organize and logically look at the information instead of just looking at the words alone. An example, let's determine if this argument is valid. I've got two premises. All fish live in the water. A trout is a type of fish. And then I have a conclusion, so trout live in the water. Well, if we go back and look at the wording here, this is saying all fish live in the water. And then we're talking about a specific type of fish. We're defining trout as a type of fish. And trout are fish, so they live in the water. So this conclusion of trout live in the water, that would make sense as being a valid statement because the conclusion has to follow since a trout is a type of fish and all fish live in water. So this would be a valid conclusion. And this one's pretty easy to just determine that by reading through the information. But sometimes they're not so easy to determine with the information. And it can be helpful to draw a picture in the aspect of a Venn diagram to actually analyze this. So let's try that here. The first statement says all fish live in the water. So that's kind of like talking about two sets. We're talking about the set of fish and then the set of things that live in water. And because all fish live in the water, we're really saying the fish are part of the things that live in water. So I have a set of lives in water that would be an outer set to the set of fish. Because fish are things that live in water, that would have to be totally contained because it says all within the lives in water set. The second statement is talking about trout. The trout is a type of fish. So the trout would have to go into, and I'm just going to, for ease, since my picture is kind of small, I'm going to use X to represent a trout. The trout would have to go into the fish set because we're talking about it being a type of fish. So what we've done here is we've taken the premises and we have drawn them into a Venn diagram. And we can use that Venn diagram to then analyze the conclusion. So the conclusion says trout live in water. Remember, trout is the X. So what we're really asking is X, the trout, in the water circle and not anywhere else. And we're talking about the water circle, which is also the water set, and not outside of it. Because it has to, for this to be a valid conclusion, the conclusion must follow and nothing else could occur. So is X in the water set and not anywhere outside the water set. So when we look at X, it is in the water set. And you might say, well, no, it's in the fish set. Well, the fish set is inside the water set, so the X, or the trout, is in the water set. And the X is nowhere else. The X, because it's a fish, has to be in the water set. It can't be anywhere else. So what this says is that, yes, indeed, X is only in the water set. It's not outside the water set, so it must be a valid argument. Okay. So what we've done is we kind of logically looked through the statements and determined the conclusion was valid, that it had to occur. And then we also used a Venn diagram to kind of diagram it. So before we do more analysis of arguments with Venn diagrams, I want to go over what a qualified proposition is and what some phrases, common phrases in English, mean in terms of drawing Venn diagrams. Now, a qualified proposition is a statement that asserts a relationship between two sets. Qualified propositions often use the words or phrases all, if then, none, or some. And when you see the words all in a sentence or the word if then, and you may recall that all is an if then disguise, those two words or phrases mean that all elements of one set are totally contained within another. So for instance, if we have the statement all cats are mammals, that's saying that all cats are contained within the mammal set. So we would have cats, the set, inside of mammals. So whenever you see an all statement, we actually are referring to one set totally contained within the other. And the inner set is always the thing that comes after all. And the outer set is what is described in the remainder of the sentence. All inside set are outside set. If then works the same way. If she is a doctor, then she knows CPR. The if part is on the inside. Doctors are inside the set of no CPR. Okay, so what we have is if an inside set, then refers to the outside set. So all and if then relate to one set being totally within another set. Now the word some is a little bit different. What it means is that there's overlap between two sets. So when I say some flying animals are birds, what we would be looking at is two sets overlapping, flying animals and birds. Okay. And this is a true statement. I wanted to just kind of go ahead and mention not all birds fly and not all flying animals are birds. So what we have here, but we definitely have some birds that are animals and some birds fly, so we have an overlap. So this is, when you see the word some, you have two sets that are overlapping in their relationship. And then the word no or none refers to two sets that do not overlap. So in this case, instead of using none, I said no reptiles are mammals. That would mean that the reptile and the mammal sets are totally distinct from each other. And understanding how the wording relates to the sets and where the sets relate to each other is important if we're going to draw Venn diagrams to analyze arguments.